So in this video, we are going to learn how to find the derivative of a function from first principle. Now, before we start solving questions, it is very important for us to know what differentiation is all about. So when we talk about differentiation, it is basically the process of finding the derivative of a function. So let's assume that we have a function y which is equal to f of x. Now the derivative of this function with respect to x is given as dy dx, which can also be represented as f prime of x, and that is equal to, now from first principle, it is given as the limit as h approaches 0 of f of x plus h minus f of x all over h, where the value of h is not equal to 0. Now we have two questions here. We are going to find the derivative of each of the functions at x equals 2 and then x equals 1 respectively. So let's try these together. A. So we want to find the derivative of f of x, which is given as 4x squared minus 3 at x equals 2. So we have f prime of x, that is the derivative of this function with respect to x, is equal to, from first principle, the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we have the limit as h approaches 0. Now we have this to be f of x plus h. Now this primarily means that wherever we see x in this function, we are going to replace that with x plus h. So we have 4x squared minus 3. So that becomes 4 into bracket x plus h all square minus 3 minus, and then this time we have f of x, which is 4x squared minus 3, and then all divided by h. Now let's further work on this equation. So we have the limit as h approaches 0. Let's try to expand this. So that is, we have 4 into bracket. Now if you have x plus h all square, then this is equal to x plus h times x plus h. So basically you have twice of this. So you multiply x by x, you have x squared, x times h, that is xh, and then you have h times x, which is also xh. So you end up having twice of them. So you have 2 times of it, that is 2xh, and then plus h times h, which is h squared. So here we are going to have x squared plus 2xh plus h squared, and then minus 3 minus, now the negative affects everything here, so it becomes negative 4x squared, and then negative becomes positive, so plus 3, and then we have this all divided by h. Let's further simplify this. Now we are going to multiply 4 across, so that's going to be 4x squared and then plus 8xh plus 4h squared. We have minus 3 minus 4x squared plus 3 all divided by h. Next we have the limit as h approaches 0. You realize that we have 4x squared and then minus 4x squared, so they cancel out. We have negative 3 and then positive 3, they also cancel out. So we are left with 8xh plus 4h squared divided by h. Now at this point, you realize that h is common to both terms at the numerator. So we can factor out h, so that we have inside of the bracket we have 8x plus 4h all divided by h. So h cancels out h, and then we are left with the limit as h approaches 0 of 8x plus 4h. Next, we are going to plug h equals 0 into this limit, and then we have 8x plus 4 times 0, and that is equal to 8x. Therefore, we have f prime of x to be equal to 8x. Now, from the question, we are asked to find the derivative of f of x at x equals 2. So at x equals 2, we are going to plug in 2 in place of x. So we have 8 times 2, and that is equal to 16. So the derivative of this function at x equals 2, which is given by f prime of 2, is equal to 16. Notice that a function is said to be differentiable at a point if the derivative of that function exists at that point. Now let's move on as we solve for b. So for b, we are going to find the derivative of the function 1 over x cubed at x equals 1. Let's solve this together. So we have f prime of x to be equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So the limit as h approaches 0 of, now we are going to substitute x plus h in place of x. So we have 1 over x plus h all cube, and then minus f of x, that is 1 over x cube all divided by h. Now the next thing we are going to do is to pull out the numerator and then try to find the simplified version of the numerator and then replace that into the limit. So let's say we have 1 over x plus h all cube minus 1 over x cube. So to find the LCM, basically let's multiply these two values. So we have x cube times x plus h all cube. So we divide this whole thing by x plus h all cube, and you realize that this cancels out this and we are left with x cube. So x cube times 1 is still x cube minus the whole of this divided by x cube. We are left with x plus h all cube times 1. It still remains as x plus h all cube. Now to expand x plus h all cube, let's say we have a plus b all cube. The expansion of this is equal to a cube plus 3a square b plus 3a b square plus b cube. So for x plus h all cube, that's going to be, so we have x cube minus, and then that's going to be x cube plus 3x square h plus 3x h square plus h cube, and then we have this all over x cube times x cube plus 3x square h plus 3x h square plus h cube. Now at this point, let's multiply -1 across. So we are going to have x cube minus 3x square h minus 3x h square minus h cube all over, we have x cube times x cube plus 3x square h plus 3x h square plus h cube. So x cube minus x cube, so they both go away, and then we are left with negative 3x square h, negative 3x h square, negative h cube. Now we are going to substitute the expanded version into this limit. So that is equal to the limit as h approaches 0 of, we have negative 3x square h minus 3x h square minus h cube all over x cube times x cube plus 3x square h plus 3x h square plus h cube, and then all over h. Now we are going to multiply that by the reciprocal of h, which is 1 over h. Next, you realize that from the numerator, h is common to all of the terms, so we are going to factor out h. So if we do that, inside of the bracket we are going to have negative 3x square minus 3xh minus h square, and then we have times h outside, divided by this h all over. We simply write this thing here, so we have x cube into brackets x cube plus 3x square h plus 3x h square plus h cube. So h cancels out h, and then we are going to plug in h equals 0 into this limit. Now each of the terms having h is going to be 0, so there's no need of repeating the terms with h. So we are going to have negative 3x square. This has h, we leave that out. This also has h, we leave that out. And so we have this divided by x cube into brackets. We have x cube, and then this has h, that is 3x square h, and then 3x h square, and then h cube. So all of them have h, so we are going to leave them out and then only maintain x cube. And so that is equal to negative 3x square divided by x cube times x cube is x to the power 6, and then we have negative 3x square, and then this comes up, so this becomes negative 6, and so we have this equals negative 3x exponent negative 4. This can also be represented as negative 3 over x to the power 4. So this is f prime of x. Now if you want to find f prime of 1, which is at x equals 1, then basically we are going to substitute 1 in place of x. So that is f prime of 1 equals negative 3 over 1 exponent 4. Now 1 exponent 4 is still 1, so negative 3 over 1, and that is equal to negative 3. Now to question C, we are going to find the derivative of f of x, indicating the interval in which f of x is differentiable. So we have f of x to be equal to the square root of 3x minus 2. We have f prime of x to be equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now this is equal to the limit as h approaches 0 of f of x plus h. So that becomes, in place of x, we have x plus h. So that is 3 into bracket x plus h minus 2 minus, and then f of x, that is the square root of 3x minus 2, all divided by h. So this is equal to the limits as h approaches 0. Now you realize that we have the numerator to be a set, and so to rationalize this, we are going to multiply both the numerator and the denominator by the conjugate of the numerator. So that's going to be, we have the square root of 3 into brackets x plus h minus 2 minus square root of 3x minus 2, all divided by h, times the conjugate of the numerator, that is for both the numerator and the denominator. So we have square root of 3 into brackets x plus h minus 2, and then this negative sign changes to a positive sign, and then we have square root of 3x minus 2. We do same for the denominator, 3 into brackets x plus h minus 2 plus square root of 3x minus 2. Now let's multiply across. So the square root of 3 into brackets x plus h minus 2 times square root of 3 into brackets x plus h minus 2. So that becomes, we have square root of 3 into brackets x plus h minus 2 all square, square root of 3 into brackets x plus h minus 2 times square root of 3x minus 2. It becomes plus square root of 3 into brackets x plus h minus 2, and then times square root of 3x minus 2, and then we have negative of this also times this, and that becomes negative square root of 3 into brackets x plus h minus 2, and then square root of 3x minus 2, and then minus square root of 3x minus 2 times square root of 3x minus 2. So we have square root of 3x minus 2 all square, and then all divided by h times square root of 3 into brackets x plus h minus 2 plus square root of 3x minus 2. Let's simplify further. So the square cancels the square roots. We are left with 3 into bracket x plus h minus 2. This is positive, this is negative, so they cancel out, and then we are left with negative square cancel square root 3x minus 2 all divided by h into bracket square root of 3 into bracket x plus h minus 2 plus square root of 3x minus 2. Now let's expand what we have at the numerator. So we have 3 times x, that is 3x, 3 times h, 3h, we have minus 2, negative 1 times 3x, that becomes negative 3x, and negative times negative becomes positive, all divided by h into bracket the square root of 3 into bracket x plus h minus 2 plus square root of 3x minus 2 equals we have 3x, we have negative 3x, they cancel out. We have negative 2, positive 2, they also cancel out, and then we are left with 3h. We can just cancel out h and then h, and then we are left with 3 divided by square root of 3 into brackets x plus h minus 2 plus square root of 3x minus 2. So at this point, we can plug in h equals 0 into this limit. So we are going to have 3 divided by, we have the square root of 3 into bracket x plus 0 minus 2, and then plus the square root of 3x minus 2. So this is equal to 3 divided by, now x plus 0 is still x, so we are going to have the square root of 3x minus 2 plus square root of 3x minus 2. Now we have twice of square root of 3x minus 2, so it becomes 2 times the square root of 3x minus 2. So that is equal to f prime of x. So we have f prime of x to be equal to 3 divided by 2 times the square root of 3x minus 2. Now looking at this function, you realize that if the value under the square root is 0, it makes the denominator 0, thus making the function undefined. And if the value under the square root is a negative value, then we are going to have a complex number. However, we are focusing on the set of real numbers. So what this primarily means is that the value under the square root should not be 0, neither should it be a negative value. For that matter, we say that the value under the square root should be a positive value, thus making the function defined. So if you want to find the interval in which f of x is differentiable, then we say that we have the denominator 2 times the square root of 3x minus 2. We are saying that this should be strictly greater than 0. So first we divide through by 2, and then we have the square root of 3x minus 2 is greater than 0. We square both sides, and then we have 3x minus 2 is greater than 0. We are going to transpose negative 2 to the right hand side, and then we have 3x is greater than 2. We divide through by 3, and then we have x is greater than 2 over 3. So representing this in the interval notation, then this means that we have open bracket 2 over 3 because it is only greater than, comma, positive infinity. So the interval in which f of x is differentiable at is what we have here. That is open bracket 2 over 3, comma, positive infinity, open bracket. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.